This slidecast presents an analysis of the research literature on technology-based problem solving, presented by Gary Miller and was prepared as a course requirement for Education 6610. Problem solving refers to important activity that happens in everyday situations as well as in professional and educational environments. We use problem solving to make sense of the world around us. Problem solving can be further divided into two categories: well-structured problems and ill-structured problems. Well-structured problems include a well-defined initial state, are organized and involve a process that leads to a prescribed solution, where ill-structured problems are vaguely defined, have multiple solution paths, or no solutions at all. Problem solving is an important theme because most people are confronted by many types of problems in everyday life, and unless they are able to solve them, they may have a great deal of difficulties in their activities. The aim of this analysis is to find sub-themes in the literature. The purpose of this analysis was to identify similarities and differences, to identify patterns, and to search for emergent themes on technology-based problem solving using a content analysis method. The analysis used the search term problem solving. 15 sources were selected from 10 peer-reviewed educational technology journals. Since all the sources were selected from educational technology journals and books, all included an electronic medium. Studies were found using theme-related keyword searches through Google Scholar, Educational Resource Information Center, and by visiting educational technology journal websites. The search criteria were refined to include only journal sources with research participants. As a result, meta-analyses and book reviews were excluded. The studies selected ranged from 2001 to 2014 and included 8 to 332 participants. 10 of the studies used quantitative data to conduct their research, while 3 used qualitative data. The remaining 2 research studies used a mixed methods approach. Participants in 7 studies were undergraduate and graduate students, while 7 other research studies discussed the investigation of 4th to 9th grade students. The final study examined pre-service teachers as participants. 10 of the studies were conducted in the United States, while 3 were from Europe and the final 2 were conducted in Asia. Studies were read and reread to uncover sub-themes that spanned across multiple studies. The sub-themes of scaffolding, collaboration, and effects of multimedia on problem solving were identified through this analysis. Boulou and Peterson defined scaffolding as temporary supports provided by the teacher or another student to help students bridge the gap between their current abilities and the intended goal. Scaffolds such as technology-based question prompts include questions, hints, examples, reminders, and sentence starters. G and Land reported that question prompts had positive effects on student problem solving. Question prompts positively affected directing student attention, elaboration skills, justification processes, and finding correct solutions. Question prompts also help students with understanding the problem, along with helping students that had different levels of prior knowledge. Herm and Jarvala defined collaboration as a coordinated effort to solve a problem together. Collaborative learning was enabled through technology, and in this analysis has been referred to as computer-supported collaborative learning, computer-mediated communication, computer conferencing, and computer-based discussion. Jonasson and Kwan found that collaboration supported problem solving through a more focused, on-task, and purposeful communication. Technology-based collaboration allowed students to distribute and share more ideas when solving problems. Chung et al. Reported that positive outcomes such as higher confidence was attributed to the number of anonymous questions that were allowed during problem-solving tasks involving real-time responses given by the instructor through computer-based discussion. Chung et al. Also observed that anonymity allowed students to ask any type of question to the instructor. Likewise, when students collaborated with peers through either asynchronous or synchronous multimedia discussion boards, significant improvements in learning occurred which affected geometric problem solving. The use of peer interactions also promoted positive effects on problem solving. Peer-generated models using multimedia whiteboards allowed students to view other students' strategies to solve problems, along with the availability of modifying and discussing others' work. The use of multimedia is an effective approach to improving learners' problem-solving skills. Using multimedia decreased cognitive load for learners throughout the problem-solving process. Student motivation and engagement have a significant impact on students' complex problem-solving skills. Iserial et al. Reported that the effects of multimedia in gameplay motivated learners to be engaged, which led to collaboration and competition, which in turn positively impacted students' complex problem-solving abilities. Similarly, Chung, Shell, and Kaiser reported that students reported being more active and engaged in their contributions, which led to learning material more thoroughly. Attitudinal measures were taken by some studies to calculate perceived ease of use, perceived usefulness, and perceived playfulness. Perceived ease of use is defined as the degree to which a person believes that using a particular system would be free of effort. Huang and Hu reported that if participants find the system easy to use, it will increase the probability of continued use. Positive measures in each of these categories indicate that participants agreed that the technology in question leads to improved self-efficacy and can help them. This analysis presented evidence to support the use of technology in problem solving. All of the studies support the argument that problem solving is an essential skill to develop and that technology can have positive effects on problem solving. Many of the studies reported the benefits of scaffolding and its effect on learners' problem solving skills. Scaffolding strategies such as prompts and hints have positive effects on student problem solving, enabling learners to improve the explanation of their thinking, understanding of the problem, and the identification of limitations and justification of their solution paths. Evidence such as improved learning, higher confidence, and higher levels of personal reflection suggest that collaboration offers many benefits to problem solving. Collaboration was facilitated by mediums such as electronic bulletin boards, synchronous and asynchronous discussion forums, along with text features within virtual whiteboard environments. Use of technology-based collaborative tools is important because it allows students to improve their focus, communication processes, and reasoning skills along with remaining on task. Collaboration was also found beneficial in problem-solving tasks that involve students within groups. This collaboration among group members is important because participants perceive technology-based collaboration as higher quality and allowed them to share and distribute more ideas when problem solving. The 15 studies in this analysis consistently support the use of technology as an effective way to encourage problem-solving skills and increase self-efficacy. Given that peer interactions promote positive effects on problem solving, Huang and Hu indicated that peer-generated models, along with modifying, improving, and discussing each other's solutions and strategies, contributed to supporting problem-solving skills. Problem solving happens in workplaces and everyday situations. Learning to solve these problems is the learning outcome of education and improves the quality of student learning. The findings of the 15 studies suggested that there are many benefits to using technology to support problem solving. Technology provides students with scaffolding strategies, collaborative structure, and an effective learning environment. The use of question prompts as a scaffolding strategy in problem solving showed positive effects on student learning and achievement. Collaboration in the form of synchronous and asynchronous discussion forums provided higher quality discussion, leading to significant positive effects on focus and reasoning skills. Several studies reported that the use of technology as the learning environment had positive effects on content knowledge, problem-solving skills, and self-efficacy. This analysis was limited by its broad scope, which included a variety of multimedia learning environments, subject areas, and prior knowledge skill sets that addressed many problem-solving skills. Focusing on one type of technology that specialized in one type of problem-solving skill could have been a boundary that changed the outcome of this analysis. As well, perhaps focusing on one technology and subject area could have changed the results of this study. For example, using 3D virtual manipulative models to solve math problems would have a more specific focus. This analysis has shown that students struggle in the areas of problem solving. It is important for educators to implement problem solving strategies to promote achievement in this area. Teachers should provide strategies to promote problem solving skills. However, there is a need to understand students with different levels of prior knowledge and how they can be supported when solving problems. Furthermore, educators need to identify communication processes that relate to enhancing problem-solving performance, which would support learners who are not as proficient in contributing to computer-mediated communication. Similarly, teachers need to develop prompts that are adaptive so that the right question is asked to the right type of learner in order to maximize their benefit. While technology helps students succeed in problem solving, a need for collaborative tools that promote peer learning and independence warrants further study. Therefore, teachers must be encouraged to participate in professional development in the use of multimedia programs and to develop computer-based instructional technologies in their classrooms and study them.